Hi grade 11s, I'm so glad that you chose to join us today. Today we are looking at compound growth. We are revising some of the important concepts that you need for grade 11 and that you need to take with you into grade 12. So of course when we spoke about compound interest in grade 10 and at the beginning of grade 11, what we really noted is that compound growth is really all about interest being calculated on interest. So basically it means that we calculate interest based on the principal amount and any interest that has accumulated over the previous periods. So the interest is repeatedly being calculated on an increasing amount, and therefore compound interest is excellent for investment, not so great for loans. Unless otherwise stated, your interest is compounded annually, which means it's added each year to the existing sum of the principal and the accumulated interest. Remember your compound interest, if you had to graph it, it would take the shape of an increasing exponential graph. The formula you use for compound interest, which most of you should be quite familiar with, A is equal to P into 1 plus I raised to the power of n. Just a reminder of what your variables are showing you. A is your final amount or your accumulated amount. How much do you end up with? P is the initial amount. What did you put in? I is the interest rate, and it's in decimal form, and n is of course your period. If you are given any of the three variables, you can always work out the fourth. So if you know A, I, and n, you can work out P. Similarly, if you know N, A, and P, you can work out I, and so on and so on and so on. This formula can be manipulated and rearranged to change the subject to find any of the variables. Okay, let's have a look at an example. So Bongani decides that he wants to put away 30,000 Rand in an investment account. So if he's going to put that amount away, already I start making note of what this represents to me. This is, or what it represents in the question, this is P. What compound interest rate must the investment account achieve? So we are looking for what is the compound interest rate? And what he wants to do is he wants to double his money. Now remember, double means 2 times the amount. So double means we need to take the 30,000 times by 2. So he wants to actually get 60,000 Rand at the end of 6 years. So n is equal to 6. We want the answer correct to 1 decimal place. Okay, so we know that the formula we're using is A is equal to P into 1 plus I to the power of n. We start out with 30,000 Rand. I is what we are looking for, and n is 6. He wants to double his money, so therefore A is 60,000. All right, so you can either write all of these, the values of the variables in and then solve for I, or you can first change the subject of the formula and make I the subject and then substitute your variables in. Either way, if you don't make any careless mistakes, you'll end up with the same thing. If we divide both sides by 30,000, 30, remember K represents 1,000, so therefore 60,000 divided by 30,000 will give me 2, is equal to 1 plus I to the power of 6. And then to get rid of the power of 6, you've got to take the 6th root on both sides. Remember, that's roots of the same power will cancel the actual power or same index. And we end up with the 6th root of 2 minus 1 will give me the value of I. All right, so let's do that on our calculator. Oopsie, we want that one, and we want that one. Let's try that again. There we go. All right. Let's move this out of the way so you can see. So we're looking for 6th root of 2. From that we subtract 1. and we get 0,11122. If we times that by 100, that tells us our rate is 12,24. So because we're rounding off to one decimal here, even though you can see that the third digit is 4, if I put in 12,2%, and you can try this, you will see that Bongani will not quite get to 60,000 Rand. So you need to actually round up. Just based on using logic and reading the question, we can see that we have to actually round the 12.2 up to 12.3 so that he achieves his goal, regardless of the fact that the number after the 2 is less than 5 in your second decimal place. Okay, so therefore it will be 12,3% that is going to get him to an investment of 60,000 Rand, where he has completely doubled his investment. So remember, it's so important to read the question carefully and to make your interpretation of the question and your answer reflect the accuracy of what the question is asking for. Okay, so even though correct is 12.2%, for the answer to actually make sense, we have to round up to 12.3%. Hopefully none of you are confused by why I rounded up there. All right, now as you've seen in compound interest calculation so far, the interest can be added more frequently. So we know that the interest calculated on a principal amount can be added more often, so it can be added semi-annually, quarterly, monthly, and so on. It can be really any regular period of time during the year. The compounding period tells us the number of times that interest is charged or earned in a year. So for example, if the period was monthly, that means that your interest will be added every month in a year. So obviously, because this compounding is no longer annual, we need to adjust the compound interest formula, because that general compound interest formula is just for an annual type of compounding. So to reflect the different compounding periods, we need to times n, our number of years, by m, which is the compounding period, and then we need to divide our interest rate by m, so also reflecting the fact that our compounding occurs a certain number of times in the year. So we multiply n by the number of times compounding occurs, we divide the interest rate by the number of times that compounding occurs. All right, let's have a look at this example. Maggie invests 12,500 Rand for 5 years at 12% per annum compounded monthly. Okay, so we can see here that M is going to be 12 because there are 12 months in a year. She invests 12,500 Rand, so that's our P. And our N is not 5 years. It's going to now reflect that it needs to be times by M, the number of times compounding occurs. So therefore, N is going to be 5 times 12, which is 60. Okay, so remember your interest rate, the compounding of your interest rate, and your N need to match up. So if we are doing 12% per annum compounded monthly, then I is going to be 0.12 divided by 12. Okay. Calculate the amount she has saved at the end of 5 years, so we are looking for A. So A would be equal to 12,500 into 1 plus I, which is 0.12 divided by 12. And then we're going to raise that to the power of 60. Okay, let's have a look at what that's going to give us. Remember that you will only round your answer off in the final step. Do not do any intermediate steps and then round off. Into 1 plus 0.12 divided by 12, and that's all raised to the power of 60. Okay, and we see that she's going to end up with 22,708 Rand and 71 cents. So 22,708 Rand and Did we say it was 71? Yes, it was 71 cents. Okay, so you can see the impact that this changing compounding period will have. In fact, you can test this for yourself. Do the very same question, but change the compounding to just annual. So instead of 12% compounded monthly, 12% compounded yearly. And you'll see that there is not hugely significant, but there is a significant change. Of course, as the money grows and grows and grows, that change becomes bigger and bigger. So basically, the more compounding periods there are in a year, the more money you will make on that investment. All right, guys, let's take a quick break. When we come back, we're looking at more compound growth.